Advanced Math Ninja Academy. So today we're gonna be focused on our new subtopic. We are still doing engineering mathematics 2, which in our case is TMAS, known as EMA 2 or 6B. So today we're gonna be focused on a new subtopic which is called homogeneous. Homogeneous of the same degree. Without wasting time, let's try to dive into it. So we have our subtopic, as I have mentioned from the previous slide, that we have homogeneous of the same degree. Our equation that is governing homogeneous of the same degree is given by dy over dx, which is equals to f into xy all over g into xy. So this is the standard form. Standard form is given by dy over dx, which is equals to f of y all over g of xy. So there are some important things that you need to keep in mind when you are solving problems of homogeneous of the same degree. Always make sure that you have this standard form. Always make sure that your equation or your differential equation that you are given, you have this standard form. For example, let's say they give you dy over dx plus x y all over x squared is equals to 0. Make sure that our equation is in standard form, meaning that you're going to transpose what you have on your left hand side to your right hand side. You're going to end up with dy over dx is equals to xy all over x squared. So make sure that your equation that you're dealing with is in standard form. And another thing that you need to keep in mind, that when you're dealing with homogeneous of the same degree, you can see that we are having variable x and variable y, meaning that we're dealing with multivariable functions. So homogeneous differential equation is given by this standard form, dy over dx is equals to f of xy all over g of xy. We're dealing with a function of two variables, which is x and y, and you must also always make sure that your derivative here is always 1. The coefficient of your derivative is always 1. So what exactly is this term homogeneous? When you talk about homogeneous of the same degree, what exactly are we talking about? Number one, when you talk about same degree, we're referring to equal exponent. So we use what we call a short test to verify that our equation is a homogeneous. For example, let's look at this one here. We have dy over dx, which is raised to the exponent 3. Okay, we have exponent 3 here, plus 3 multiplied by x is raised to the exponent 1, and then we have y squared. It means we have 1 plus 2, which give us 3. Okay, the exponent is the same. And then if you look at x cubed, we have exponent 3. So we have our equation which is homogeneous. Why? Because we have our exponents to be the same. We call this the short test. We add the exponent of each term to see what you get. If the exponent are the same, it means you have homogeneous of the same degree. So just to quick recap on what we covered, we have homogeneous of the same degree, homogeneous of the same degree. I mentioned that the standard form is given by dy over dx, which is equals to f of xy all over g of xy. Don't be confused. The lecture might use n or m in place of g and f. This just simply means this function of f is a function of multivariable. It consists of x and y. And then let's go and look at the method now. How do we approach? We're looking at the approach. Number one, the first thing which you're going to do, you're going to let y to be equal to vx, and then you're also going to let your derivative, which is the y over the x, to be equal to v plus x dv all over the x. This is the first thing which you're going to do. You're going to let y to be equal to vx, and then you're also going to let the y over the x to be equal to v plus x dv all over the x. After doing that, you're going to solve. After solving, you're going to end up with dv all over dx. When you reach this point, you're going to use separation of variable. And then the last point is that the moment you finish to solve your equation, your differential equation, the moment you finish solving your separation of variable from homogeneous of the same degree, you're going to let v to be equals to yx, then you make y to be equals to something. Okay, let's go through this again. First thing first that you're going to do, you're going to let y to be equal to vx, and then you're also going to let your derivative to be equal to x to v plus x dv all over the x. And then step number 2, you're going to solve whatever that you have after letting y to be equal to vx, and after letting your derivative to be equal to v plus x dv all over the x. And then after solving, here I was just mentioning that if you solve that equation, you're going to end up with separation of variable, and then you're going to separate the variables. After separating the variable, you're going to solve, and at the end of the day, you need to make v to be the subject with the formula, and then after substituting v, which is equals to yx, and then you make y to be the subject with the formula. Let's just try to put this into a practical, because I might talk and it might make sense now, but you might get confused when you have to do it on your own. So we have this problem. Let me just use this example.